In Lesson 5.8, you will be learning about scale drawings and models. You'll be able to use scale drawings and also construct scale drawings. Remember, the essential question for Chapter 5 is, how can you identify and represent proportional relationships? We will be using proportions to do our scale drawings and models. Make sure to write down the definitions of your vocabulary words. A scale drawing or a scale model is used to represent an object that is too large or too small to be drawn or built at an actual size. And the scale is determined by the ratio of a given length on the drawing to its corresponding length on the actual object. So we'll be using that moving forward on our indirect measurement project and other problems involving scales, where we have the given length on the drawing and then we have the actual object's length. So we'll be using that on our example problems here for Lesson 5.8. In example 1, we are given the information on our models, and our job is to find out the scale. So in example 1, got it, at the bottom of the page, I went ahead and set up the proportions for you. The pillars of the World War II Memorial in Washington, D.C. are 17 feet tall, and then the model has pillars that are 5 inches tall. Notice in this example, I chose to put 5 over 17. So 5 inches in the model over 17 feet actual equals 1 inch over x. So in this case, we can cross multiply and divide, or we can use a calculator. I'm going to take 5 times x to get 5x, and 17 times 1 to get 17. I failed to mention we could also do this problem mentally, because 17 divided by 5, I can do that and make that a mixed number, which is 3 and 2/5, or we could write that as 3.4. So what is the scale model? We would say that 1 inch equals 3.4 feet. Notice in 1b, I set it up just a little bit different. I put the actual length as the numerator, 50, over the model, which is 16. And then x, we're trying to find the the scale, x over 1 inch. Okay, so in this case, if I cross multiply, 50 times 1 is 50. I'll go ahead and put that up here. And then 16 times x is 16x. Divide by 16, divide by 16. Again, you can use a calculator, but I can do this mentally. 50 divided by 16 is 3, with 2 left over. So that's 3 and 2/16, or 3 and 1/8, which I believe, if I turn my answers on, they have it as 3.125, or 3 and 1/8. And then, of course, 1b is 1 inch equals 3.4 feet. Okay, again, using cross products or setting up the proportion, all used in conjunction with solving these scale problems. For example 1. On the next page, example 2, we're looking at, again, using a scale factor to solve problems, and it walks you through 2 different methods. Method 1 is using a proportion, where again they have everything laid out into the plan length and the actual length, plan length to the actual length. And setting up a proportion, they cross multiplied 1 times x, and then 6 times 11.4, and then we get 68.4. The other method here is to find the scale factor, where 1 inch equals 6 feet. Notice they changed that to 1 inch is 72 inches, so we have common measurements. So the scale factor is 1/72, or the actual length is 72 times the blueprint. Notice they plug that into that formula we've seen before, which y equals kx. K is that constant of proportionality, in this case 72 times the blueprint, and again the a and the b no different than y and x. So once we have that formula or that equation, we can substitute in the 11.4 and get the same answer of 820.8 inches and then or 68.4 feet. Both methods give you the same answer, and I went ahead and did both methods for example 2 at the bottom of page 225. Let's go ahead and change the color here of the pen and walk through both methods. So we have a map of a dinosaur exhibit room that's 7.25 inches wide. I put that right there. And the scale on the map is 1 inch over 8 feet. So 1 inch over 8 feet. Notice that we have inches in both numerators, and then we're solving for the feet here. Okay? If I cross multiply and divide, it's going to be pretty easy because I have 1x and I don't need to divide by anything. So all I need to do is pull up my calculator and take 8 times 7.25, and I get my answer of 58. Or the second method as described above is that we can find that constant of proportionality. I can say 1 inch is 96 inches. Where did I get the 96 inches? Well, if I'm making that ratio, I want to make sure I have common measurements. So I just changed 8 feet to 96 inches. So the actual length is 96 times the blueprint, which means I can put that in for my constant value. Again, a and b, I could write that as y equals 96x. And then I can substitute in my value of 7.25. And when I take on my calculator 96 times 7.25, you might say, well, that's not the same answer. But remember, in this method, we have the same measurement terms, and so this is actually 696 inches. So if I divided that by 12, I would get the same answer, 58 feet. So try to use both methods when you're practicing this on your homework. We're not going to go through example 3 in the book, but I would like for you to read through that and make yourself familiar with how to draw that. But your homework is actually going to be working on scale Ella, and you'll have the worksheet for that. There's a QR code to scan that video and then complete the worksheet that I give you. Let me know if you have any other questions.